Hello guys, I hope you're doing very well. Today we are going to carry on learning more advanced techniques of integration, and today is the turn of learning trigonometric substitution. The idea behind trigonometric substitution is to be able to recognize some patterns, some expressions that can be easier if we do some substitutions. For example, the first one, a squared minus x squared. If we apply the substitution x equal a times sine of theta, then dx will be equal to a times cosine of theta d theta. The second expression that we have to recognize is the one given by x squared minus a squared, in which we have to do the substitution x equal a times secant of theta. Then dx will be equal to a times secant of theta times tangent of theta d theta. Finally, our third expression that we have to recognize is given by x squared plus a squared. If we do the substitution x equal a times tangent of theta, then dx will be a times secant square of theta d theta. For instance, let us consider the integral of the square root of 4 minus x squared dx. If we apply the substitution x equal 2 sine of theta, then dx is 2 cosine of theta. And if we substitute in the previous integral, we have the integral of 2 times the square root of 4 minus 4 sine square of theta times cosine of theta d theta. And this can be written as 4 times the integral of the square root of 1 minus sine square of theta times cosine of theta d theta. Now, we know that 1 minus sine square of theta is equal to cosine square of theta. And as it's inside a square root, we end up having 4 times the integral of cosine of theta times cosine of theta d theta, which is 4 times the integral of cosine square of theta d theta. Now, cosine square of theta can be written as 1 plus cosine of 2 theta divided by 2. Thus, we have the following integral: 2 times the integral of 1 plus cosine of 2 theta d theta. And after some substitution, we can have the final result for this integral in terms of theta. And that will be equal to 2 times theta plus sine of 2 theta plus c. Now, in order to be able to solve the integral, the original one, we need to be able to solve it in terms of x. And for doing so, we need to consider the following right triangle. Remember that x is equal to sine of theta. Thus, sine of theta is equal to x over 2. And theta will be equal to arcsine of x over 2. Now, as you can see in our right triangle, and knowing that sine of 2 theta is equal to 2 sine of theta cosine of theta, our final result is the following: 2 arcsine of x over 2 plus x, the square root of 4 minus x squared divided by 2 plus c. Now, let us consider the integral of dx over x squared plus 9 to the power of 3 halves. If we do the substitution x equal 3 times tangent of theta, then dx will be equal to 3 times secant square of theta d theta. And by applying such a substitution, we get the integral of 3 secant square of theta d theta divided by 9 times tangent square of theta plus 9 to the power of 3 halves. Now, such an integral can be simplified as 3 over 27 times the integral of secant square of theta d theta divided by secant cubed of theta. And after some simplifications, we get 1/9 times the integral of d theta divided by secant of theta, which is equal to 1/9 times the integral of cosine of theta d theta. Thus, the integral is equal to 1/9 times sine of theta plus c. But now, in order to solve the original integral, we need to be able to solve it in terms of x. Now, remember that x is equal to 3 tangent of theta. Thus, tangent of theta will be equal to x over 3. Therefore, we have everything we need for our right triangle. And we can do the proper substitution knowing that the final result is x over 9 times the square root of x squared plus 9 plus c. Let us consider our final example, the integral of x squared dx divided by the square root of x squared minus 16. Now, if we do the substitution x equals 4 times secant of theta, then dx is equal to 4 secant of theta tangent of theta d theta. Thus, after applying the substitutions, we get 16 times the integral of secant cubed of theta times tangent of theta d theta divided by the square root of tangent square of theta. Now, if we simplify the previous expression, we get 16 times the integral of secant cubed of theta times tangent of theta d theta divided by tangent of theta, which is equal to 16 times the integral of secant cubed of theta d theta. And such an integral, which can be solved by applying integration by parts, is equal to 8 times the natural logarithm of the absolute value of tangent of theta plus secant of theta plus 8 times secant of theta tangent of theta plus c. Now, we need to be able to express such a result in terms of x, knowing that if x is equal 4 times secant of theta, then secant of theta is equal to x over 4. Therefore, cosine of theta is equal to 4 over x. And we can express our right triangle for each side. Now, if we apply the substitutions in terms of x, we get that our final result will be equal to 8 times the natural logarithm of the square root of x squared minus 16 plus x divided by 4 plus x times the square root of x squared minus 16 divided by 2 plus c. Show me what you've learned in this lesson by solving the following integrals. And well, guys, see you in the next video.